Um, 24. Here we go. 12, 45. Can't do anything else with that, so it's either 45 over 12, maybe you can. Yes, you can. Divide by 3. 15 over 4. Okay, now you can convert it back or leave it as that. How many times is 4 going to 15 without going over? That would be 3. And you have 3 left over your denominator. 3 3/4. There we go. Oh gosh. Long day. I just made the video way longer. Okay, so next, determine the missing number, 1, 3, 7, 13, 21. 1, 3, 7, 13. Oh, I just said the answer. Okay, whatever. I mean, basically what I look for first is any patterns between the differences of these numbers. That's usually the pattern. So let's see, the difference between these is 2, 4, 6. Now what do you think the difference between these two are going to be? Well, we got 2, 4, 6. That's a pattern. It's going up by 2. So it must be 8. What's 8 plus 13? 21. I mean, that was a pretty easy pattern to recognize. Going on to the next one, prime factorization of 360. Not too hard. You've done these like every essentials. So 360, automatically think. If you have a 0, and then if it's divisible, you know it's divisible by 10 if it ends in a 0. Okay? So you divide by 10, 36 times 10. Because when you multiply 10, you're basically just adding on a 0 to that number. So if I do 36 times 1,000, then I add on 3 zeros, right? Makes it easy. If I do 48 times 1,000,000, you're like, oh, yeah, duh. Okay, you add on 6 zeros, and there's your answer already. That was easy. It's easy to multiply by multiple to 10. And so 10 breaks down into 5 and 2. Those are both prime. 36 breaks down into 6 and 6 breaks down into 3 and 2s. So you have 1, 2, 2 3s times 1, 2, 3 2s times 1, 5. There's your answer. 3 to the second times 2 to the third times 5. Yep, that's right. Am I doing? Okay. Find the GCF of 48 and 54. Greatest common factor. Okay, not multiple, so you're not going to write out 96 and 108. Those are multiples. We're trying to find factors. So if we think of factors of 48, of course every factor of everything is 1, except for 0. And then we have a 2. Well, let's go ahead and put a 48 over here. 2 times what is 48? 24. 3. Having a brain fart again? Nope. Yep. 3 and 16. 4 and 12. I think that's 6 and 8. Crap. 6 and 8. Okay. Factors of 54. 1 and 54. 2 and 20. Oh my gosh. Why can't I think of it? 27. 3. Possibly. I always forget it. It's 18. 4. No. Okay, 6 and 9. I think that's all of them. So we're looking for the greatest common factor. It means the factor that's the greatest in that it can be, and it's both factors in both of them. 1 is obviously not, because we got 2's right here, which are not, which we got 3's right here, which are not. We got 6's in common. We don't have, we can cross out this 4 up here. We don't have 16's in common, or 12's. We don't have 8's in common, we don't have 24, we don't have 48, so it's got to be 6's. 6 is your greatest common factor. Okay, so you got to go through that big long process to find the GCF. And that's just building on your logical thinking. I know you think, why in the heck am I learning this? But it's logical thinking. Find the area. You know the area is pi r squared. So 15 squared is 225. 225 pi. There's your answer. Which, if you want to multiply that out, then you get 706.85. 706.85. There's your answer. Number 8, more order of operations. You see a divide sign that goes first in the PEMDAS scale. 49 divided by 7 is 7. Combine like terms, which is -2 plus 7, which is 5. 2n plus 5 is equal to 15. That's your equation that we've gotten to so far. So subtract the 5, because you're trying to get m on one side, but you have 2m on one side. It's 2m is equal to 15 minus 5, which is 10. And so to get m on one side, you got to get rid of that coefficient. So what do you do? The opposite of multiplying is dividing, so divide by 2, and you get m is equal to 7.5. No. Oh, duh. 15 minus 5 is 10. 10 divided by 2 is 5. M is equal to 5. There you go. So you just got to kind of memorize different situations. Like if you have 3, I don't know, I just wrote a pi. 3x over 4 plus 2 is equal to 13, or something like this. Okay. In this case, we cannot multiply by 4. Why? Because there is no common denominator here. That's a denominator of 1. We could change it to a 4 denominator. I don't know how that would help us. Which it would, I guess. Yeah, if you change that to a 4 denominator, that's fine. But it's so much easier just to subtract this 2 first. So subtract 2 from both sides. That cancels that out. 13 minus 2 is 11. So we're left with this. You're dividing by 4. We want to get rid of that because we can't divide by this 3 yet. So we have to multiply by 4 because the opposite of dividing is multiplying. And the reason for that is, think about it. Right here, this is the same as saying 1 over 4. Yeah, this 4 is basically saying like 1 over 4. So to get rid of that 4, we're going to have to make it equal to 1, right? Because if it's equal to 1, then 1 times 3 is going to equal 3 still. It's like identity. So if we multiply by 4 over 1, and we multiply across, hey, we get 4 over 4, which is equal to 1. So when that's multiplied by 3, it doesn't change it at all. So we've gotten rid of that 4. But we've got to multiply the other side by 4. So we get 3x is equal to 44. And to get rid of that 3, you divide both sides by 3. I don't care about dividing that, I'm just showing you an example. So you got to really critically think in these kind of equations. You'll be doing a lot of algebraic solving like this. It's lots of fun. It'll get hard. Nearest thousandth to 0.0795, and that's going to be 0.08